y equals 4 over x times x minus 2. Well, if we want to sketch this, let's use our usual sequence. Ideas. Intercepts. For the y-intercept, set x equal to 0. Well, if I put x equal to 0, y is actually undefined. I'm dividing by 0. Y is undefined. This actually tells me I've got a vertical asymptote here, which I'm going to find in the next step anyway, so I'm going to leave it till then. For the x-intercepts, set y equal to 0. Well, actually, that's not possible. 4 on top of the fraction will never be 0. That's just not possible. There are no y-intercepts, there are no x-intercepts. Discontinuities. Well, we already know about one of them. Discontinuous when the bottom of my fraction is 0. X minus 2 is 0, which means x equals 0 or 2. So these are vertical asymptotes. Extremities. Extremities. As x approaches plus or minus infinity, what's going to happen? Well, I've got a constant number divided by something with x in it. Actually, it's x squared. As x gets very large, positive or negative, this is going to get very, very large, so the whole fraction is going to get very, very small. And y is going to tend towards 0. And I have discovered a horizontal asymptote. Oops, forgot the p again. All right, asymptotes. Does my graph ever cross these asymptotes? Well, we already know it doesn't. When x is 0, I can't work out y. When y is 0, well, actually, y will never be 0. So, graph does not cross asymptotes. I almost know enough to sketch the graph already. What about any stationary or other special points? Let me draw a quick sketch and see where I get to. I know I have an asymptote here. I also know x equals 2 is an asymptote. And I know y equals 0 is an asymptote. Now what I really want to know is where's my graph going around these asymptotes? What I can do is I can write it like this. As x approaches negative infinity, what's y going to do? Well, as x approaches negative infinity, this will be negative, this will be negative. I've got a positive divided by a positive, negative times negative, so y is going to be positive but close to 0. 0 from above. So this notation means 0 from above. You can, if you prefer, write from above. The next point of interest is x equals 0. As x approaches 0 from the left, from below, what's y going to do? Well, if x is very close to 0, but negative, then this is negative. It's close to 0, so this is negative. I've got a negative times a negative. I should have a positive. Positive infinity. Now, I should have known that anyway, because if my graph is starting above 0 and finishing and doesn't cross those asymptotes, then it's going to have to finish up here. It must be at positive infinity. What I don't know is what happens next. As x approaches 0 from above, from this side, what's happening? Well, x is close to 0 but positive, so that's positive. This is close to 0, so this is still negative, and I now have a negative on the bottom. So it's now negative infinity. Next point of interest is 2. X is approaching 2 from below, from the left. Well, I should already know it was going to negative infinity. It can't cross these asymptotes, so it's going to have to go back down here, but let's check. X is 2, but just below. So this is positive. This is just less than 2, so this is going to be negative. So the bottom of my fraction is negative, and I am indeed approaching negative infinity. What about my last section? As x approaches 2 from above, what's going to happen? It's basically 2, so this is positive. This is just above 2 now from the right, so just above 2, this is going to be positive, and my underneath of my fraction will be positive. So y is approaching positive infinity, and it's up here. Now it's not allowed to cross the asymptotes, so it's now going to approach from above, but let's check. As x approaches positive infinity, what's y going to do? This is positive, y is going to be close to 0, but greater than 0. It is indeed going to be 0 from above, which is here. I can now make a sketch. This one is going to come down across to here, and this one is going to come down across to there. This one has to come up. There's going to be a maximum point there somewhere and go back down again. It would in this case be helpful to me to find out where that stationary point actually is. I'm going to have to differentiate. Y equals 4 over x minus 2. Now if I have to differentiate that right now, it's a product on the bottom. It's going to be a mess, but I can make it a little bit simpler. First expand those brackets. 4 over x squared minus 2x. Now write this as a power on top. 4 x squared minus 2x to the power of negative 1. Now I can differentiate this using the chain rule. Y dashed is going to be 4, differentiate the thing in brackets first, minus 1 times the thing in brackets to the negative 2 times the derivative of the inside of the brackets, which is 2x minus 2. Write that more simply as a fraction. Negative 4 2x minus 2 over x squared minus 2x squared. All I care about is the top of this fraction. It's 0 when, well, 4 can't be 0, so it has to be when 2x minus 2 is 0, which means x minus 1 is 0, or x has to equal 1. I have found a stationary point, and it even matches my graph. If this is 0 and that's 2, this could well be x equals 1. Let's work out the y-coordinate. Y here is 4 over, x is 1. 1 times 1 minus 2. Well, that's 4 over negative 1, which is negative 4. So I can get my graph and put the coordinates of that point in here, 1, negative 4. And there's my completed sketch of that graph.